the eigenvectors today. Now, yesterday's problem itself, we are going to continue. What was the yesterday's matrix, students? If you have your notes with you, what is the matrix? Matrix says, again, I am writing this matrix here. Matrix says, can anybody dictate matrix A?
3, 1, 4.
Just wait, it is a matrix 3, 1, 4. Then
0, 2. 0, 2, 6.
0,
6.
2, 6. Okay.
0, 0, 5.
0, 0, 5. And can you tell me the eigenvalues also, which we got yesterday? We got eigenvalues, right?
2, 3, 5.
2, 3, 5. Thank you. So these are your eigenvalues. Okay. Now, what was the question, students? Question was asked, find the eigenvalues and eigenvectors of the following matrix, right? So first part already we did, that is to get the eigenvalues by using shortcut method. Now today I am going to tell you how to find eigenvectors. Now look here carefully. To find the eigenvectors, already I have written here, you have to solve this matrix equation. What is that matrix equation? A minus lambda I x is equal to null matrix. Okay. This is called as matrix equation. This equation itself will give you 3 eigenvectors corresponding to 3 eigenvalues. Now see how to go about it. If I have put the open bracket here, no problem. So now properly matrix equation. A minus lambda I means, as I told you, you have to subtract lambda from the diagonal elements, right? So it is 3 minus lambda, 2 minus lambda, 5 minus lambda. Remaining elements will remain same. Why? Because you are subtracting 0 from that. Correct? A minus lambda I. So lambda into I means what? I is the identity matrix of the same order. So it is lambda 0, 0, 0, lambda 0, 0, 0, lambda. So when you are subtracting that matrix from this, only the diagonal elements will change. All other elements will remain same because you are subtracting 0. Okay. X is the matrix of unknowns, x1, x2, x3. Right? You can take x, y, z also, no problem. And null matrix is of this type. Okay, so see students carefully how I wrote the matrix equation. This is the same method for all problems whenever you are finding eigenvectors. A minus lambda I x is equal to the null matrix. Any doubt you can ask me. This is your matrix A. Always name it as A. Now this is the main equation in which all your eigenvalues will go one by one. Okay, so let us start with first eigenvalue. Put lambda is equal to lambda 1 is equal to 2. Order is not important, as I told you, any eigenvalue you can take at first place. But usually I take in ascending order. So lambda 1 is equal to 2. So what is going to happen here, students? Wherever there is lambda, I am replacing it by 2. Correct? So 3 minus 2. 3 minus 2 is what? Should I write this step, or 3 minus 2 is 1, right? You'll understand this if I directly substitute, right? 0 will remain same. 2 minus 2 will become 0. Then 6 will remain same. 0, 0, and 5 minus 2 is 3. And this is x1, x2, x3. And this is null matrix 0, 0, 0. Okay, students? All of you understood what is happening here? So wherever there is lambda, I have replaced it by 2. Okay. Now one more thing. When you write this matrix equation, this equation will give you total 3 equations. What are these 3 equations, students? It is x1 plus 1x2 plus 4x3 is equal to 0. It's what exactly I'm doing? Row into column. correct, is equal to 0. Second row into the column, that is 0x1 plus 0x2 plus 6x3 is equal to 0. And then 0x1 plus 0x2 plus 3x3 is equal to 0. Okay, is that clear? Now, when you write these equations, how to solve these equations? Now, to solve these three equations, what you are going to do is, you are going to consider any two different equations from these students. Okay. Now, for example, you have to see if something is common in the first equation. Cancel that term. So, nothing is common. So, I'm writing the first equation as it is. X1 plus x2 plus 4x3 is equal to 0. Correct? Second equation is just 6x3 is equal to 0. It means that x3 is equal to 0, right? Because if I cross multiply by 6, it is going to give me 0 itself. Similarly, in the third equation, if I cross multiply by 3, I'm going to get 0 itself. So, out of these two equations, only one equation you have to take because both the remaining equations are same. Otherwise, also you have to choose any two distinct equations to find eigenvectors. Either you choose first two, last two, first and third. It is your choice. You are going to get the same thing. Okay. Now look here, students. What I did? First, I wrote the matrix equation. I replaced lambda by the eigenvalue. Then I wrote three equations. Three equations may be different. Two will be same, one will be different. All three equations may be same. So there are different cases. Okay. Now, once you choose two different equations, see what happens. If you remember the Cramer's rule which you have done in your earlier classes, what we used to do is this. This is the determinant, students, in the denominator. X1 upon the determinant minus x2 upon the determinant and x3 upon the determinant. Determinant means the minor of your matrix. Now, why the middle sign is minus? Because when you solve 3 by 3 determinant, students, you remember that middle sign is always negative, opposite. Okay. Now, see carefully what I do. When I write denominator for x1, you have to ignore the first column, right? Just ignore the first column. What are the numbers here? What are the coefficients? 0, 4, 0, 6, right? 0, 4, 0, 6. Correct? Then when you write denominator for x2, ignore the middle column. What are the coefficients? 1, 4, 0, 6. Getting? When you write denominator for x3, what are the elements? 1, 1, 0, 0. You followed what I did? See, first you write like this. x1 upon the minor, x2 upon minus x2 upon the minor, x3 upon the minor is equal to some constant k. This constant k may be any number. Okay. Then when you write denominator for x1, you have to hide x1 column and write all the coefficients 0, 4, 0, 6. When you write denominator for x2, hide x2 column 1, 4, 0, 6. When you write denominator for x3, hide x3 column and write 1, 1, 0, 0. Any doubt, you can ask me in chat box, students. And now see what happens, what numbers you get. X1 upon, you cross multiply, right? 6 into 0 is 0, 0 into 4 is 0. How you solve 2 by 2 determinant? Same way, is equal to minus x2 divided by 6 minus 6 into 1 is 6, minus 4 into 0 is 0. And x3 divided by again 0 minus 0 is 0.
Ma'am,
Yes.
ma'am, we are hiding in the x1, ma'am, we are hiding the first column, so it will be 1, 0 and 4, 6 now.
When you are hiding the 1, 4, it
First,
will be, no? Yes, yes, yes. This will be 1, right?
yes,
Correct.
ma'am.
When you are hiding this, it will be 1406, no? 1406, correct? So it will be 6 here. 6 into 1 is 6 minus 0. Correct? Yes, students? Then when you are hiding middle one, it will be 1406. When you are hiding last one, it is 1100. Okay? Now see what you get here. It is, I'll continue on the next page. Okay. So see what we got here. x1 by 6 minus x2 by 6, x3 by 0 is equal to k. Is that clear, students? Now, when you are writing eigenvector, what you have to do is, you are going to write it in the simplest form. Simplest form in the sense what? x1 by 6 is equal to x2 by minus 6 is equal to x3 by 0, because this k is some unknown constant, arbitrary constant, right? This minus sign I have taken down C. Okay. So your eigenvector is capital X1 is equal to 1 minus 1 0. Means if some number is common, you have to cancel that common number. In other words, x1 by 6 is equal to k means what? x1 by 1 is equal to 6k, right? Understand this method. Huh? So value of x1, that is the first value is 1. x2 by minus 6 is equal to k means what? x2 is equal to minus 6k. So what is the denominator? It is 1. So denominator values are the elements of your eigenvector. But how to write these values? If some number is common, you have to cancel that number. Common number you have to cancel, and whatever remaining small numbers, that will be the eigenvector of your matrix. If it is not common, suppose 2, 3, 5 are coming in the denominator, then you have no choice. You have to take 2, 3, 5 as it is. Okay. Now at the same time, what I am saying is, when you write this x1, basically it is k into this. If k is 1, what will happen, students? For k is equal to 1, it will be x1 will be equal to 1 minus 1 0, right? If k is equal to minus 1, what will be x1? It will be minus 1 1 0. Means all the 6 signs will be opposite. Okay. As you go on changing values of k, you are going to get different eigenvectors. That's why I have said in the beginning that eigenvectors are not unique. So yesterday I have given you some tips here. The eigenvector of matrix A is not unique. Eigenvector is never 0. That is a null matrix. Okay. Every eigenvalue we get corresponding eigenvector. So remembering these properties, you can say that eigenvectors are not unique. But to solve the problem, you have to take one fixed eigenvector, students, and that we take as 1 minus 1 0. So this is, you no need to do this part. This is just for explanation I have taken. You need not do it. But some students may write it as 1 minus 1 0. Some students may write it as minus 1 1 0. Means what? If k is minus 1, then plus will become minus, minus will become plus, right? That is also correct. So any one you can take, but don't take 6 minus 6 0, because 6 is common. Always cancel it. Always bring it in the simplest form. Okay. So this is your first eigenvector. Any doubt, students, you can ask me. You can hear me, right? Yes, somebody has said something in the chat box. First one is, okay. Any doubt, students? Should we proceed for second eigenvector? Okay. Now, you have to put lambda is equal to lambda 2. What is the second eigenvector you got, students? It is 3, right? Where you are going to put it? In the same equation A. Same matrix equation A. Now see, where is your matrix equation? Here. This is your matrix equation A. So wherever there is lambda, you are going to put 3. So 3 minus 3 will be 0. 2 minus 3 will be minus 1. 5 minus 3 will be 2. And all other numbers will remain same. Okay. So let us write this. Three minus 3 is 0. Then 1, 4 will remain same. Then 0 will remain same. 2 minus 3 is minus 1. 6. 0, 0. 5 minus 3 is 2. Tell me if I'm going wrong anywhere, because single sign mistake will give you wrong answer. Okay. So this is your equation. Now again, go for your 3 equations. What will be the equation, students? Now see, 0x1 plus 1x2 plus 4x3 is equal to 0, right? Then 0x1 minus x2 plus 6x3 is equal to 0. And 0x1 plus 0x2 plus 2x2 is x3 is equal to 0. Set of three equations, row into column. Okay. Now once you get three equations, it is your choice which equation you want to take, which two equations. Okay, but those two equations should be totally different. That is the must condition. Okay, so you see which this you want to take. So suppose I wish to take first two equations. You can try with different equations, students, but finally we all will get the same eigenvector. Some students can take last two, some students can take first and third, and let us try. Okay, so I taken first two equations because I can clearly see that nothing is common, and though these equations are same or different. Sometimes what happens, three equations you get whenever you are getting the repeated eigenvalues, and three equations, they looks different but they are same after cancellation of common factor, after adjusting the signs and all. So you have to be very careful. Now let me write x upon the determinant minus x2 upon the determinant and is equal to x3 upon the determinant, and the right hand side is k. Okay. Now when you are writing denominator for x1, hide x1 column and write the coefficients. 1, 4, minus 1, 6. 1, 4, minus 1, 6. Correct, no? 1, 4, minus 1, 6. Okay. Then hide x2 column 0, 4, 0, 6. 0, 4, 0, 6. Then for x3 it is 0, 1, 0, minus 1. 0, 1, 0, minus 1. Is that clear? Okay. So what we get here? X1 divided by 6 minus minus plus 4. How you solve 2 by 2 determinant? Same thing, cross multiplication with minus sign in between. First you have to start from this 1 to 6. So this diagonal, left to right diagonal minus right to left diagonal. So 6 plus 4 is equal to x2 divided by 0, right? Because 0 minus 0 and minus sign will get cancelled. Don't forget to take minus sign down. Is equal to x3 divided by, again 0 minus 0 will give you 0. So basically what you get, students, here, you get x1 by 10 is equal to x2 by 0 is equal to x3 by 0 is equal to k, right? So when you write your second eigenvector, are you going to write 10, 0, 0 or 1, 0, 0? It is 1, 0, 0 because there is only one known number 10. So if you divide this by 10, you get 1, 0, 0. Basically outside will be k. So if k is 10, then it will be 10, 0, 0. If k is 100, then it will be 100, 0, 0. You followed what I'm saying? So always try to cancel the factor, common factor. Make it in the simplest form. Can you tell me what other simplest form will be correct for this? If k is minus 1, what will happen? Minus 1, 0, 0. So if some students are getting minus 1, 0, 0, they are also correct. You followed what I'm saying? There are infinitely many eigenvectors, but you have to take the simplest form. Means nothing should be common in the numbers under the eigenvector. Anybody has tried with any other equations? See if you can try with other equations also and see if what you get, students. Are you getting same eigenvector or you are getting different eigenvector? Try. Same. Okay. Deval is getting same. Deval, which two equations you have taken?
First and third.
First and third. Very good. Anybody has tried second and third? You will get the same eigenvector. Okay, so it is your choice. Done? Done with the second eigenvector. Now one more is remaining, that is the third eigenvector. So to find third eigenvector, what you are going to put is, put lambda is equal to lambda 3, and what is the third eigenvalue, students? 5, right? Okay. Now this is your matrix equation A. In this matrix equation A, you are going to put lambda is equal to 5. So 3 minus 5 is minus 2, 2 minus 5 is minus 3, and 5 minus 5 will be 0. All other elements will remain same. So only you are replacing lambda by 5 in equation A. And now see what you get. Equation A becomes 3 minus 5. 3 minus 5 is minus 2. Then this is 1, 4, 0. 2 minus 5 is minus 3, 6, 0, 0, 0. 5 minus 5 is 0. And this is x1, x2, x3. Please tell me if I am going wrong anywhere. And then this is your null matrix 0, 0, 0, right? So 3 minus 5, 2 minus 5, and 5 minus 5. Okay, now let us write three equations. So see what happens. Minus 2x1 plus x2 plus 4x3 is equal to 0. Then 0x1 minus 3x2 plus 6x3 is equal to 0. No need to write the third equation because it is meaningless. 0 is equal to 0 it will be, right? 0x1 plus 0x2 plus 0x3 is equal to 0. You cannot take that equation into consideration. Okay. So first two equations are clearly different from each other, and therefore take these two equations into consideration. So x1 upon the determinant minus x2 upon the determinant, x3 upon the determinant is equal to k. Okay, so see what happens now. X1 upon, hide x1 column, so it is 1, 4 minus 3, 6. 1, 4 minus 3, 6. Hide x2 column, minus 2, 4, 0, 6. Minus 2, 4, 0, 6. Hide x3 column, minus 2, 1, 0, minus 3. Minus 2, 1, 0, minus 3. Correct? This is minus 3, okay? Minus 3, 6. Okay, now let us write the numbers which we got here. So this is x1 divided by, what is this? 6 minus minus plus 12, right? It's equal to x2 divided by minus x2 divided by 6 to the 12 minus 0. x3 divided by 6 minus 0 is equal to k. Right? And then what are the numbers you are getting here, students? See, it is x1 divided by 18 is equal to x2 divided by minus 12. Minus x2 by minus 12 is x2 by 12. I am cancelling minus sign. And it is x3 divided by 6 is equal to k. Okay. So now I want to write x3. Who will be able to tell me this eigenvector? Adira, can you tell me the eigenvector? Bipin has already told. Okay. Yeah.
3, 2, 1.
3, 2, 1. Because 6 is common here, students. So you have to cancel 6. So it is 3, 2, and 1. Very good. So nothing is common here. What else can be also correct, Adira? What else can be also correct?
Minus 3 to 1.
Minus 3, minus 2, minus 1. You have to change sign of each and every
2
element.
minus 1.
You understood? It is not enough to change sign of one or two elements and say that it is correct. Because when k is minus 1, all elements of eigenvector will get multiplied by minus 1, right? So this is also correct eigenvector. So in this way, you got 3 eigenvalues and 3 eigenvectors. Okay, students? Okay, now One more example. Now take this problem. Find eigenvalues and eigenvectors. Find eigenvalues and eigenvectors of the matrix A is equal to simple one I am giving you 0 1 1 1 0 1 and 1 1 0. Okay, 0 1 1 1 0 1 and 1 1 0. Now see students, go step by step. To find eigenvectors, first of all you need to find out eigenvalues, right? So step number 1. If you have understood, you can proceed. Don't wait for me to solve. And you can put your answers in chat box. So I'll come to know that you already understood, right? In step number 1, you are going to find eigenvalues, right? To find eigenvalues, as the given matrix is of order 3 by 3, we can go for our shortcut method. Now see what is the shortcut method, students, which we use. It is lambda cube minus sum of the diagonal elements, means 0 plus 0 plus 0, right? Lambda square plus the determinants, 3 determinants, first 4 numbers plus last 4 numbers plus the corner elements. And this is coefficient of lambda, and the last term is negative determinant of A equal to 0. Okay. So this is our shortcut formula. So it is lambda cube. Can you excuse me for 1 minute? Is it readable, students? Yes, okay. So this is your shortcut formula. Now what happens, see, lambda cube minus 0 into anything is 0, so there will not be any lambda square term existing. Now this you can do 0, this will be minus 1, this will be 0, this will be minus 1, and this will be 0, this will be minus 1. So isn't it minus 3 lambda? And anybody got value of the determinant, students, on the calculator? Because usage of calculator gives you accuracy as well as your time also gets saved, right? So instead of going for traditional way, take help of calculator. If you have still not learned the calculator on the calculator matrix functions, it is very important to learn. It is not difficult at all. Once you do it twice or thrice, you can find out determinant value on the calculator. You can find out the inverse on the calculator. You can multiply 2 matrices, 3 matrices on the calculator. Right? So can anyone tell me what is value of this determinant? You can put in chat box. Arbaz is saying 2. Okay. So value of the determinant is 2, but that minus sign is inbuilt, right? And therefore it is minus 2. Suppose value of the determinant is negative, then don't forget to make it positive, okay? Minus, minus, plus. So very carefully you have to solve, students, these things. Okay. Now this also, again calculator comes into the picture. You can go to the equation mode and see what are 3 roots. 2 minus 1 minus 1. Very good, correct. So you know that you need to get 3 roots, students, right? Because it is cubic equation. But what calculator will show you? It will show you 2 comma minus 1, is it? So as I told you in the beginning lectures, you have to assume that the last number gets repeated. Is it minus 2 minus 1 or 2 minus 1 minus 1? Check. 2 it is, correct? So these are the roots you should get, all of you. But without checking whether your eigenvalues are correct, because these are your eigenvalues, right? Without checking the accuracy of the eigenvalues, don't proceed to find eigenvectors. So what is the method I told you? How to check whether your eigenvalues are correct, students? Sum of eigenvalues should be same as sum of diagonal elements of given matrix A. So this I told you in the beginning. Now what is the sum of eigenvalues? See, it is 2 minus 1 minus 1. And what is the sum of your diagonal element? 0. So this is 0, right? 2 minus 2 is 0. So you are getting 0 by 0 is equal to 0. So the condition is satisfied. So you can say that whatever numbers you got, these are correct eigenvalues. In case this condition doesn't work, then you should understand that something is wrong in your formula or some mistake you have done while finding the roots or in the characteristic equation. Okay, so without checking for the eigenvalues, don't proceed. So once you get the eigenvalues, the first step is over, students. Now you will go to step number 2. What is step number 2? To find eigenvectors. Correct? Now, to find eigenvectors, what we do here is you have to write the matrix equation. Same steps I am following. What is that matrix equation? A minus lambda I x is equal to null matrix. Correct? Now what is A minus lambda I in this, students? Just subtract lambda from the diagonal elements. So 0 minus lambda, 0 minus lambda, 0 minus lambda, right? And remaining elements will remain same. This is 1, 1 and this is 1, 1. So in this matrix, this is a given matrix, no? So I am subtracting minus lambda into I. I means what? Identity matrix, no? 1, 0, 0, 0, 1, 0, 0, 0, 1. So 0 minus lambda, 1 minus 0, 1 minus 0 will remain 1, 1. So in this way, directly you can write this. Any doubt, students, please ask me in between. You can put in chat box or you can unmute yourself and ask the doubts. If you're not asking, means I think that you have understood. Okay. If you want me to reduce my speed or increase the speed, you tell me. Now this is x. X is x1, x2, x3 or xyz, anything you can take. And the right hand side is your null matrix. And this is your equation A, students. So while finding eigenvectors, your equation A is very important. In this equation itself, your all eigenvalues will go one by one. Okay. Any doubt till this step, students? If no, then I'll proceed with the next step. I'll take another page for this. Okay. Now see, I'll rewrite equation A here. Equation A is minus lambda 1 1 1 minus lambda 1 1 1 minus lambda x1 x2 x3 is equal to 0 0 0, and this is your equation A, correct? And as I said, in equation A, all our eigenvalues will go one by one. So first what I'll do, first I'll put lambda is equal to lambda 1 is equal to minus 1. Okay, let us go in ascending order, minus 1. Now see carefully what happens. Wherever there is lambda, you are replacing it by what? You are replacing it by minus 1. So what happens? Put this in equation A. So minus of minus 1 will become plus 1, students. Correct? Then this is 1 1. This is 1 1. Correct? And this is your x1, x2, x3. And 0 0 0. Okay? And now tell me what happens here. x1 plus x2 plus x3 is equal to 0. x1 plus x2 plus x3 is equal to 0. x1 plus x2 plus x3 is equal to 0. Okay. Now here the situation is such that all three equations are same. Sometimes what happens, students, sometimes you get the equation with multiple of 2. For example, 2x1 plus 2x2 plus 2x3 is equal to 0. It is also same as x1 plus x2 plus x3 is equal to 0 after cancellation of the common factor, right? So here there is no question to choose any two different equations because all three equations are same, right? And as I told you earlier, whenever there are repeated eigenvalues, you come across the same same equations. Now here this minus 1 is repeated twice. So these equations are same. So let us see how to go about this. This is the same equation, right? Now see, there is one equation and how many unknowns? 3 unknowns, right? So suppose R stands for number of equations and N stands for number of unknowns. Then you have to take N minus R number of random variables. Random variables means we cannot call it as variable. You can say that random constant means 2 number of random constants you are going to take as K1 and K2. Now let me explain. Here there is single equation, but how many unknowns? 3 unknowns, right? So you have to choose any 2 as K1 and K2. We have seen the similar situation when we were doing the system of equations. Whenever there was one equation with 2 unknowns, we used to take one unknown as K and another unknown we used to get in terms of K. You followed? But here 3 unknowns and 1 equation. So take x1 as K1 and x2 as K2, your choice. Any 2 variables you take as K1, K2. So what this will give you, see, what will be x3 here, students? X3 will be minus K1 minus K2. Correct, no? So in short, what will be your eigenvector here, students? X1 is K1, X2 is K2 and X3 is minus K1 minus K2. Correct? Now this single eigenvector is going to give you 2 different eigenvectors. Because you have seen that this minus 1 is repeated twice, right? Same eigenvalue, minus 1. So same eigenvector with K1, K2. Now, how to proceed? You have your own choice to choose K1 and K2, students, right? what you want to take as K1 and what you want to take as K2. So choose K1 and K2. Suppose I want to choose K1 as 0 and K2 as 1. What will happen? It will be 0, 1, and this will be what? Minus 1. Again, I am telling you, this is not unique. If somebody wish to take another values for K1, K2, but how to choose the values, students? These values should be in 0 and 1 itself, maximum minus 1. Don't choose big numbers so that something comes common there. Okay. Now here what I'll do, I can interchange. This is not compulsory. It is your choice. K1 is 1 I'm taking and K2 is 0. So what will be the eigenvector? See, K1 is 1, K2 is 0, and this will be minus 1. Are you understanding what I'm saying? Okay. So I'm getting 2 eigenvectors in a single step. Why it is so? Because eigenvalue is repeated twice. Okay, all of you understood what I did here? Whenever the situation comes where the equation is same, you have to choose any 2 variables as K1, K2. Get x3 in terms of K1, K2. And choose your own values for K1 and K2. So these are 2 eigenvalues, x1 and x2. Okay, students. Done. Any doubt in this? If you have any doubt, even if it is minor doubt, you can ask. Don't hesitate to ask the doubts. Now, there is one more eigenvalue, students, that is lambda is equal to 2. So you need to find out what is the eigenvector for lambda is equal to 2. So now put lambda is equal to 2 in your equation A. Right? So what is your equation A, students? This equation, right? Matrix operations on kind 10. So wherever there is lambda, you are putting 2 for this. So minus 2, 1, 1, 1 minus 2, 1, 1, 1 minus 2, x1, x2, x3 is equal to 0, 0, 0, right? So let us write this. Minus 2, 1, 1, 1 minus 2, 1, 1, 1 minus 2, x1, x2, x3 is equal to 0, 0, 0. Okay. Now can you write 3 equations, students? First equation will be minus 2x1 plus 1x2 plus 1x3 is equal to 0. Then 1x1 minus 2x2 plus 1x3 is equal to 0. And 1x1 plus x2 minus 2x3 is equal to 0. So this is set of 3 equations. Now if something is common, you can cancel the common term, but I don't say anything is common. So all these 3 equations are different from each other, right? So as I told you, let us take different set of equations and we'll check our eigenvector, right? So if I'm choosing first 2 equations, some students can try with last 2 equations and some can try with first and last equation. So that doubt will not remain in the mind that we may get different eigenvector, right? So I'm choosing first 2 and x1 minus 2x2 plus x3 is equal to 0, right? And then as usual, x1 by the determinant minus x2 by the determinant and x3 by the determinant is equal to k. Now what are the coefficients? When you write denominator for x1, the coefficients are 1, 1, minus 2, 1. Right? When you write denominator for x2, it is minus 2, 1, 1, 1. Minus 2, 1, 1, 1. Correct? Tell me if I'm going wrong anywhere. Minus 2, 1, 1, 1. Okay. Then denominator for x3, minus 2, 1 and 1 minus 2. And then x1 divided by, this is 1 minus minus plus 2, minus x2 divided by, this is minus 2 minus 1, x3 divided by 2 to the 4 minus 1 is equal to k. And then x1 by 3, x2 by 3, I'm cancelling minus sign, and x3 by 3 is equal to k. Correct? So usually students, when you're finding eigenvectors, some number comes common, which you can cancel and get your eigenvector. So what will be x3 here, students? 1, 1, 1. Cancel 3. And it is same as minus 1, minus 1, minus 1 also. Okay. Anybody has tried with other numbers, other equations, and you are getting different answers? Okay, all are getting same. Anybody is having any doubts, students? Okay, tell me one thing. Have you studied matrix functions on calculator, all of you? Or still there are some students who didn't do it? You've done it, right? Okay, how much time is left? It's almost 5 minutes only, no? 5 to 6 minutes. Okay. Do you want to solve one more example? 5 minutes, Akash. Okay then. Next time I'll do the diagonalization of a matrix. In that, these two are the steps which you have to do first, finding eigenvalues, eigenvectors, and then there is something called as diagonalization of a matrix. Right? That I will discuss in the next class. So will you give the attendance? Today's 22nd, right? Okay, give the attendance. Bipin is there, no? Bipin is there. So 1, 2, 3. 3 is absent. 4, 5, 6, 7. 7 is absent. 8, 9, 10, 11. 11 absent. Okay, 12, 13, 14, 14, 15, 15, 16, 17, 18, 19, 20, 21, 21, 22, 23, 23, 24, 25, 26, 27, 27, 28, 29, 29, 30, 30, 31, sorry, absent, 31, 32, 32, 32 is also absent, 33, 34, 34 is not there, no? 35, 36, 37, 38, 39, 39, 40, 40, 40 is absent, 41, 42, 43, 44, 42 is done. 42 only. 43 is not there. 43 is the last number, right? Okay, and I want to thank Ishan because he's really doing good job of recording the classes, and the picture quality and the voice and all everything is coming proper. Okay, so thank you very much, Ishan. And okay, okay, thank you. And one more thing, Ishan, I want to tell you that if you are remaining absent by any reason, then please give the responsibility to somebody else. Yeah. So please, no, you just keep two students because I don't know whose internet connection is proper and also you just discuss with them and just keep ready two students to record the class. Okay. Yes. Thank you very much. See you in the next class.